The law of conservation momentum just says that the momentum of any closed system does not change. Remember, anytime you see something that says conservation of, it just means whatever that is does not change. Then they give you two definitions, and it's really easy to get these mixed up. I suggest maybe making flashcards or something for them. So a closed system does not gain or lose mass. Okay, so a closed system has to do with mass. And an isolated system has to do with forces. And that's when the net force on that system is 0. Okay, so that's a F net equals 0. And this has to do that your mass at the beginning is equal to your mass, this should be initial, your mass at the end. And again, I would do something to like take notes and just make sure that you have a way to keep those together. So with the law of conservation of momentum, we can now do conservation of momentum problems. First thing I want to do is I want to tell you to look up the definition of a sticky and non-sticky collisions. I want you to make flashcards of those and memorize those along with a closed and an isolated system. So when we do these sticky or non-sticky collisions, there's a couple things. Basically, we'll say that the momentum of one object initially plus the momentum of the other object initially will equal the final momentum of both objects. Okay, and I'm gonna call it circling it, but really I'm making a rectangle. Okay, now this part right here you can use for any collision. Okay, any conservation momentum problem. But this part right here is only for sticky collisions. And I'll tell you about sticky collisions in a second. Now, a sticky collision is one when the two objects start together and then when they end, they're stuck together and they go on together. And so you can tell this one is for a sticky collision because the final velocity of both is the same. So you can use this part for a sticky collision, but this part, the top part, you can use for anything. A non-sticky collision is when they hit each other and then they go off separately. We'll do a sticky collision practice problem in the next video, and then we'll also do kind of what's the opposite of a sticky collision. You have this astronaut and he's at rest in space and he's going to shoot a bullet or a burst of air or something like that, and he's going to go in the opposite direction. So that's kind of the opposite of a sticky collision because they're starting together and they're ending separately. So this is really the end of conservation momentum, but I want you to make sure that you have this. This is not technically one of our formulas. Momentum is, but not this. So you won't have this on your test, on your formula sheet. This is going to be something you kind of have to remember, like the formula you guys like to use for the elevator problems.